When we last left off, we had just made sure that Strisk could run through our main menu multiple times using a concept called recursion. But to put more simply, is simply that at the end of the function, we call the function again by name, passing it the values of money and number of widgets, thus allowing us to repeat the process over and over again. Alright, so let's carry on. Getting back to our design document, let's go down to the buy. So when we buy, there are a few things that have to happen. First, we do have to display the cost. We do have to ask them how much they want to buy, which we've done. We have to make sure that they've confirmed for it. And we also want to make sure that we stop them if they can't afford it. You know, we cannot allow them to go into the red. So let's go and add in that part now. And what we're going to do is we're going to go right here to the buy part of the function, and we're going to figure out what the cost is. Now, while it is an option to go and do all the cost stuff here, since we are having to get the user's confirmation, get the cost, and then make sure that the user can actually pay for it before we move on, I'd rather not do the cost assessment right here. Instead, I'm going to do what's called abstraction. Alright, this is going to be one of our first abstractions in programming. Abstraction is where we write a complicated function and then call that function. So that way we are able to use a small little section of code here rather than fill up a few lines. So I'm going to call a function which does not exist yet called validate by, and I expect this validate by to return either the cost of the product or some other special codes in the event that the user does not want to buy it or if the user cannot afford it. Now, in order for the validate by function, which won't be inside this file, in order for it to be able to know if the user can afford it and know, well, just to be able to know if they can afford it or not, it does need to know how much money the user has, and it also needs to know how many widgets the user wants to buy. So I'm calling this function, which does not yet exist but will soon, and I'm giving it how much money the user has and how many it wants to buy, so that way we can figure out whether or not they can afford it, as well as all the other pieces. Alright, so we're going to go File, New File, and just right away let's save that new file. We're going to call it Strisk validate. And again, that's all as one word. No spaces, no periods, none of that. We will use periods later on, but, well, probably will. But for now, we're going to leave that alone. So just save it as Strisk validate, no spaces. And right now it's empty, but it's going to have the validate by function in it. Let's go and start that off by defining our validate by function and passing it money and quantity. Now here's where I want to take a quick pause and point out that it is true that these are not the same words as here, but that's okay. They don't have to be the same. They can be anything, but it is always wise to use words that are close to it. When you name variables, name them based on what they are supposed to represent. While a lot of our earlier labs are purely academic exercises, you know, it'll be things like, hey, read in a number. Now print out that number minus 21. Print it out squared. You know, it's just, it had no real purpose beyond just practicing the skills. A lot of the programs, however, that we go into now, as we are maturing as programmers, they are going to involve a real context. Each of those pieces of software are supposed to do something. They should not just be going through the motions, but rather they are achieving purposes. In order to help this, it is best to name everything in logical ways. There are a lot of different ways to call things. You know, I can do money, M, points, Strill points, but try and come up with your own consistency here. For me, I'm going to keep using money, since that's what I've been using across all these. So there we go, that's just my little spiel about variable naming while programming. Let's go ahead and finish up validate by. So validate by needs to figure out the cost. So let's figure out from our design document what the cost actually is. If I go down here, it says cost is equal to 5 plus x minus y, where x is the number of widgets and y is a random number between 0 and x. Alright, good. So we're going to be adding in a random number today using our random number generator. I'll talk about that more in a few moments. Let's write our cost formula. I'm going to write as a comment first, 5 plus quantity. And notice that I'm actually filling in what x and y are. I want to write something that's similar to what the actual code will be. This is not exactly what it will be. We'll actually use rand int, not just something called rand, but rand int. And we'll see that in a moment. But notice, for you more advanced programmers, you're noticing already that this is very similar to the actual function that we will use. Those of you who are less advanced can still hopefully notice that, I'm using something much closer to what actual programming would probably look like. Your comments, you have very little space, so you want them to be as descriptive as possible, but as concise as possible. So moving on, let's actually make a variable for cost. Equals 5 plus quantity. Again, pretty much the same thing I wrote up there. And then I'm going to minus, and write this with me, random dot rand int. Now, you know int already. That's integer, right? Well, rand int returns a random integer between two values. I'm going to put it in here. It's between 0 and quantity, right? Because that's what's in the design document. So between 0 and quantity, it's going to return what we call pseudo-random number that is in that range. Let's say I had the number 10 for the quantity. Well, then the cost would be equal to 5 plus 10 for 15, and then minus a random number between 0 and 10. The reason for this is as follows. In the game Strisk, you are supposed to get a price that is fluctuating. You see, when we put in a random chance, we are technically adding the fun to the game. Or at least we're adding the addiction part of it. Gaming tends to be considered to be more fun, or at least more addictive, more engaging, when you have this randomized element in it. You'll see that in a lot of different games. Many gamers, especially those of you out there who are just really into today's more modern games, you'll talk about the RNG, the random number generator. The random number generator is what we're accessing here. And technically it is a pseudo-random number. Pseudo meaning false. You see, it does not technically get us a truly random number, not theoretically anyway, but it's going to be close enough for our purposes. The point of that whole tangent was just giving you the context on what this is and why. In the same way that there are certain ingredients you add to cooking to make the food taste better, you add randomness to a game to make it more fun. The second part that this does, this randomness actually does have quite a purpose. You see, when we get the price, we're first adding up 5 with the actual quantity, the quantity of however many widgets the user wants to buy. Meaning that automatically we have a price that is higher than the number of widgets that they want to purchase. However, then we subtract a random number between 0 and the number of widgets, meaning it could bring the price down a lot, or it could only go down a little bit. If we had quantity of 10, let's say that was it. If quantity was 10, then 5 plus 10 is 15, and we subtracted a random number between 0 and 10, let's say we get 7, that would mean that our cost would be 15 minus 7, 8. So that does bring down our price for 10 of them down to less than 1 strill point per widget. However, if we got a random number between 0 and quantity, and that number was actually 0, then we have 15, which is more than the number of widgets the user is purchasing. This formula allows for that randomness to occur, making the game less predictable. And of course, more addictive. So, moving on, we got that cost. And if we try to run this now, I'm going to go ahead and try it. And I want you to see that it doesn't work yet. I'm going to go back to Strisk main. There are going to be 2 errors we got to get through. Let's go and run our module. It's going to ask me for a name. It's going to ask me if I want to buy, sell, or quit. Well, remember, it's buy that we were just testing, or we just added to. So we're going to test buy. Ask me how many I want to buy. Let me resize this. Let's just look at it. All right. So let's say 10, like in our example. It's going to crash, and it's going to say it's going to crash because validate by is not defined. So just like how in main we had to add in the import statement in order to access main menu, so too will we have to do that in validate by. Or no, sorry, not in validate by, but rather in the menu. So let me go up here to the top line of the menu, because validate by exists in Strisk validate. We're going to have to import Strisk validate. So we're going to do that like we do normally, from Strisk validate import everything. And again, that everything is that wildcard character, the asterisk. Means we're importing all the functions that'll be in there, and we will have one more function in that file. But yeah, so now we've gotten that one out of the way. The next one you're going to see is over here with random. I want to show you that. There's your name, yes, want to buy, 10, okay, good. So it says random is not defined. So here's the same process, even though we did not write a class called a file called random. Random is a file that natively exists in Python. It is what we call a library. A library contains a bunch of functions and such, and it can be used by other Python files. But in order to get it, we do have to import it. Now, I'm going to import this one slightly differently, and I'll explain why in just a moment. Import random. Notice how I didn't start with the word from, like how up here I did with from Strisk menu import asterisk. Here I'm just saying to import the file itself. I'm doing this because I really just want to show the fact that I can do random dot down here, such that if I were to rewrite this part right here, do random dot and then rand int, and right there it'll catch on to what I'm talking about. It knows that's supposed to be A, B. Give me a random integer in range, and then the rest of that says including both A and B. Alright, cool. So that is how we do that one. And we do have to write this random dot here since we imported it like this. If I were to change it, like I'm about to do, if I were to change it to from random import everything, and then just removed this, then it would run fine. Doesn't do anything, but it would run at least. It doesn't crash. If I were to change it to the other one, import random, and just do it like that, again, it would also be just fine. And let's just leave it in this form right here. So we've now tested it, at least that it doesn't crash. But it doesn't really do anything yet either. So let's go and do some things. One is I want to have a confirm option. So let's go ahead and get that in there. We need to make sure that the user wants to actually purchase it. I'm going to put that right down here. Confirm option. Alright. In addition, we also want to make sure the user can actually afford it. So we'll check if affordable, and then we'll have a confirm option, and then we'll return based on that. Alright, so let's begin. Check if affordable. Alright, so if the user's money is greater than or equal to the cost, or let's go the other way. Check if not affordable, much easier. If money is less than the cost, as in he cannot afford it, then we're going to return a special value. And I'm going to say return -1 right here. Now, the reason is this. Eventually, this function, if the user can afford it and does want to buy it, is supposed to return the price tag, right? It's supposed to return how much it actually costs. But here's the thing. What if they can't afford it? How is my other function supposed to know? Remember, the other function is the one that's actually calling it right here. How are we supposed to know in that case? Well, like I said earlier, we're going to be using some special characters, or special codes. One of them is going to be a -1. -1 in this case is special because we're trying to get a price tag, and you don't have a negative price tag, so, I know that I can use that value to mean this instead. Such that if I'm back here in Strisk menu, and I said if cost equals -1, then I can say, sorry, you cannot afford that. Right there, because I know it works that way. Let's go on. I'm going to write an else statement here inside Strisk validate. Now, I don't actually need to, and I'll explain why at the end of this, but let's go ahead and go through this first. So if the user can afford it, this is for the case of only if affordable, only if they can afford it. We're going to ask them selection equals input. It will cost that much. Are you sure you want to buy? And I'll expand the window a little bit so you can see it. Alright, so it costs that much. Are you sure I want to buy? Let me do my typical \n/t. Alright, so it's going to ask them if they want to buy it. If cell.lower, make sure we just get that lowercase version of it. If that is equal to, no, let's go ahead and get that handled. So if the user does not want, then we're going to return a -2, yet another special code we can access, another impossible price tag, so it's another good option for us. So I'll return that, and then this is another else that I don't need, but we're going to have it anyway. Now, if they can afford it, so if they can afford it, meaning they don't stop here, because this return will immediately exit the function, and they don't not want it, so we don't stop here either. In that case, we go ahead and return the cost as it is. Now let me explain why we don't need that else or that else. And you can try this on your own, removing it and seeing what happens. You will need to tab everything back, but we don't actually need it. The reason is that whenever we return, we exit the function. So here's the thing. Typically, we want to make sure that if the money is greater than or equal to the cost, then we do all these things. And only in that case, so we use this else. However, if the money is less than cost, we've already returned, and we ignore everything else in this function, and simply return to this line over here. So we actually don't need an else there. For the same reason, we don't need it down here either, because if the selection wasn't for no, then we haven't returned, and we could just go right down here. But if it was for no, then we have returned, and we completely ignore the rest of the function. Now I'm going to go ahead and remove it so that way you can see what that would look like if I didn't have those else's in there, but then I'll return it to normal. So I'm going to get rid of that first else, bring this one back, bring that one back, get rid of that one, and there we go. And that would work the same, because if they stop here, they exit, but if they don't, they go on. We ask them if they want to buy it, and if they don't, we exit. But if they do want to buy it, then we just get the cost. But I'm going to return it back to normal by undoing. All right. And my reasoning is this. We've been learning if statements as branching paths, and I like to keep that appearance. Here's this branching path, here's this branching path, here's a branching path, here's a branching path, and that allows us to just have a little more readability of our code. Later on, I will be not doing that. You will be seeing me not having those else's that are unnecessary in there. Unless, of course, the else is necessary. But, you'll see that I'm going to stop doing some of the unnecessary stuff. That makes it easier, because eventually we want to be to the point where we can read it anyway. Anyways, that's for the future. This is now, we're good here, right? We've handled both cases where the user doesn't buy it, and then in the case where they do, we get the cost. So now, I'm going to actually minimize Strisk validate. because I can almost ignore it for a while. Until we get to sell, I don't need to worry about Strisk validate. Let's add this in now, though. We've gotten the cost, and it's either going to be a -1 for they can't afford it, or it's going to be a -2, which means that they didn't want it. So we'll just say, okay, never mind then, because they don't want to purchase it. And otherwise, we're going to go ahead and actually make the purchase happen. So let's get to that. Our money is going to go down by the cost. Our widgets is going to go up by the quantity. All right, cool. Now, reading back over this segment of code, these 7 lines I have added, it can be a little hard to figure out what's happening here. So let me just add in another comment. If cost is -1, so that means user can't afford. -2 means user does not want. And this last one is user can afford it and wants to purchase widgets. Cool. And just like that, we have added in the buy part. We have the confirm, we have the cost, we ask for quantity, we check if they can afford it, all that. And notice how all that's kind of handled in this function right here. This is why it's an abstraction, because we're able to ignore that whole piece now. Instead of scrolling around through it and making this function longer, we just have to handle this part. Because otherwise we are perfectly fine just condensing that whole thing. That whole thing of all this into this one little line right here. Okay, so let's go and move on. Let's test our code. All right. So it asks if I want to make a if I want to buy, sell, or quit. Again, we've been testing buy. So it asks me, do I want to buy? I'll say 10. All right, so right there it says the cost is 13, right? So that right there is that point where I said, where I asked how much it'll be based on how much it will cost. So we asked them how much do they want to buy. I'm going to say yes, and that will lower my points by 13 and increase my widgets by 10. This is because after I make these changes here, and we go to the end of the file, end of the function, we call it again, this time with m and w still, but m and w have been changed. So we're able to keep these variables changing around. Let's go and buy more. I'm going to go to buy. I'm going to buy just 6 this time. It says it will cost 5, so that pretty much reduced our cost by quite a bit. That random number did. So anyways, because it went down from 11 down to just 5. So yeah, do we want to buy? I'm going to actually say no this time. So it stops. Notice that it does not subtract from my points, does not add any widgets. I can hold out for a better price. Buy 6 again, cost 11, that's not a better price, so we'll say no. Still doesn't subtract anything. I'm going to try it again. This time I'm going to capitalize it. So again, doesn't make any changes. Let's handle the one for not afford. Just buy a lot of widgets. We'll see what happens. It says sorry, cannot afford that. So it doesn't make any changes. Let's go ahead and buy those 6 widgets again. Cost 7. Yeah, I'll take that. So it subtracts 7, adds 6 over here, and we're good to go. And just like that, we have managed to make our buy work. Sell is extremely similar to that. We'll just have validate sell. All right, and that's going to about do it for this part of our lesson. We've gotten buy to work pretty much entirely. Sell is just the other part we have to work on, which we'll see in the next video. Thank you for following along, and ask me any questions as needed. See ya.